Okay guys, so today we're looking at 1.1 in our new blue books. So the title is Square Roots of Perfect Squares. So we're looking at finding square roots of perfect squares, but they're not in whole number form. They're going to be either as a decimal and a fraction. So just to get ourselves started and think about how would this be possible to take the square root of a decimal or fraction, we can think of the opposite of a square root, which is squaring. So for the first example here, they take 2/3 and they square it. So that's taking 2/3 and timesing it by itself. And they end up with the fraction 4/9. Likewise, they do the same with 1.5. They square it, so it's a decimal and they square it. So 1.5 times 1.5, and they get 2.25. So 4/9 and 2.25 would be considered perfect squares, because if you remember what's a perfect square, it's a number that can be found by multiplying another number by itself to get it, right? So the product of two equal factors. So product is multiplying, two equal mean two the same, and then numbers that multiply to make it. So basically with that understood, then we could take the square root of 4/9, we could take the square root of 2.25, and we could get what we started with back before we squared. So it is possible to square root fractions and decimals. We just have to think about what fraction and what decimal then would have been multiplied by itself to get it to begin with. So looking here at example number 1, the first question is calculate the number whose square root is. So basically what this question is saying is the square root's already been found, so this is the answer to the square root problem. What was the square root to begin with? So what was underneath that square root? So calculate the number whose square root was 5/8. So thinking backwards, 5/8 is the answer, so the question would be, if I need to take 5/8 and times it by itself, that's what's going to give me that number under that square root sign. So that's what we do in the solution here to find that number that was square rooted. We take 5/8 and we multiply it by itself. So remember, when you're multiplying fractions, you multiply across the top, you multiply across the bottom, and then we get 25/64. So the answer would have been, when you take the square root of 25/64, you get 5/8. Okay, same for this over here. We're taking 1.2 and timesing it by itself. So remember, if you're going into intro, try not to use a calculator with any of this work here. So if we're needing to multiply 1.2 times 1.2, think of 12 times 12, which is 144. And then I've got one decimal place, two decimal places, so my answer would be 1.44. Okay, if you're not going into intro next year, then go ahead and use a calculator. So here the answer would have been 1.44. So doing a check, so same kind of question, calculate the number who had this square root. So what was that perfect square? So for 3/8, we need to take 3/8 and times it by itself. So that's going to be 3 times 3, which is going to give us a 9 on the top. And then on the bottom, 8 times 8, which is going to give us a 64 on the bottom. So it would have been 9/64 would have been the number that when you take the square root, you get 3/8. And here for 3/2, we're taking 3/2 and we're timesing it by itself to find that number. So it would be 3 times 3 on the top and 2 times 2 on the bottom. So 3 times 3 is 9, 2 times 2 is 4. So the answer would be 9/4. So those are kind of tricky because you're thinking backwards, right? What is the number you're taking the square root of? So with that, you have to take the answer and times it by itself. Okay, here, 0.5 times 0.5. Like I said, if you're trying to use without a calculator, you'd be thinking of this as 5 times 5, which is 25, and then one decimal place, two decimal places, so then it would be 0.25. So if you take the square root of 0.25, you get 0.5. And same here, 25 times 25, so that's beyond what's on our list there, but you might know that one, where you can do it long multiplication on the side. So it's going to give us a 625. And then we've got 1 decimal place, 2 decimal places, so that's 6.25. Okay, so for those ones, you're taking the number and multiplying it by itself. So for the next question, now we're actually going to be taking the square root. So the question is asking, are these fractions perfect squares or not? So the criteria for a fraction to be a perfect square is the number in the numerator, so the top of the fraction needs to be a perfect square, so that's on your list from the 1 to 20, right? So 1, 4, 9, 16, 25, so those are all perfect squares, so make sure you have your list out while you're doing this. So if the number on the top is on your list of perfect squares, and the number in the denominator on the bottom is in your list of perfect squares, then the fraction is considered a perfect square. So looking at the first one, if you look down your list, 16 is on the list. We can get it by multiplying 4 times 4. 25 is on the list. We can get it by multiplying 5 times 5. So 16 25ths would be considered a perfect square. For 9 20ths, 9 is on the list, but 20 is not on the list, right? There's 16 and then it jumps all the way to 25. So because 20 is not on the list, then the whole fraction would not be considered a perfect square. So you have to check top and bottom, and you can reduce. Sometimes it doesn't work, but then when you reduce the fraction to lowest terms, it works. So watch for that. So for 9 over 49, 9 is a perfect square, right? It's on our list. 3 times 3 makes 9. Okay, remember the idea of a perfect square is you could literally make the area of that by building a square with equal length times width. 49 is a perfect square. It's on our list. We get it by 7 times 7. So then 9 49ths works. It is a perfect square. 25 over 13. 25 is, so that's made by 5 times 5. But 13 is not a perfect square. It's not on our list. So there's no, because there are no 2 equal factors. Equal factors. Okay, so 25 over 13 is not, or isn't, or whatever you want to put in here, is not a perfect square. Okay, and then 64 over 81. So looking at numerator and bottom denominator there, 64 is on our list. It's 8 times 8. And then 81 is on our list because 9 times 9 works for it. This is why it's a good idea to have those perfect squares memorized or have your list out so you can refer to that list. Okay, and then once we know something is a perfect square, we could take the square root of it. So to take the square root of a perfect square, we're looking at what 2 factors make up the numerator that are equal, what 2 factors make up the denominator that are equal, right? We can break 9 into 3 times 3. We can break 4 into 2 times 2. So then the answer would be 3 over 2. So just look at the top and the bottom separately to figure it out. So here on the top we get a 4, square root of 16. On the bottom we get a 9, square root of 81. Okay, so now we're going to look at decimals. So in our rational numbers unit, we did talk about terminating and repeating decimals. Terminating decimals are ones that end after a certain number of decimal places. There could be 1 decimal place, there could be 10 decimal places, but at some point it does end. A repeating decimal is one that there's a pattern in the digits, and remember how we'd use a bar to represent that pattern. So we can kind of see a breakdown of different decimals here. So terminating 0.5, 0.28 is terminating. Repeating, we can see the 3's repeat here for that one. This one, the 1 and the 9 repeats, so we can write it with the bar on the top there. But then the special category of non-terminating, non-repeating, you can see the dot, 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 and that's where the numbers would go to the end of your calculator window because they keep going forever. You just run out of room on your calculator. So if you remember from our rational numbers unit, these numbers were called irrational because they didn't terminate and they didn't repeat. Okay, so basically we can check if a decimal is a perfect square by taking the square root. So you can use a calculator to find out. If the square root ends up being a terminating decimal or a repeating decimal, then we've got a perfect square decimal. But if not, then we've got a non-perfect square decimal. So we'll have a look at that on the following as we come to it. So basically here, is each decimal a perfect square or not? How do you know? So one strategy is to use your calculator. So if you were going into Essentials Math next year, that would be the strategy that you would look towards. So you would use your calculator. If you use your calculator for 1.69 to take the square root button, so use square root 1.69, you would get 1.3. So 1.3 terminates, it ends. So because it ends, 1.69 is considered a perfect square. Okay, for the next one, 3.5, taking the square root, because 3.5 with your calculator gives you this decimal that does not repeat and does not end, you would say that this is not a perfect square. Okay. On a side note, if you are planning to go Introduction to Applied and Pre-Cal next year, you should look at trying to figure it out without a calculator. So one of the main strategies is to look at the digits in the decimal number. So for example, this one would have the digits 1.6 or 169. So you'd think about on your chart or in your memorized first 20 perfect squares, is 169 on there as digits? So they are. They're 13 times 13. So that's your first check. So first you're checking to see if those digits make up a number on your perfect square chart, and that you should have memorized. And then secondly, you're looking at the number of decimal places. So for a number to be a perfect square, looking at decimal places, it cannot terminate in the 10th place. And why that would be is because if you think of 1.69, if it terminated in the 10th place, so say it was 1.6 instead, if I wrote that as a fraction, so 16 over 10, and then I went to take the perfect square, or like the square root of it, 16 would be good, but 10 isn't. So 10 is not a perfect square, so it would never work to take the square root and end up with a whole number. So when you're checking decimal places, a number ending in the 10th place doesn't work, but a number ending in the 100th place does work. So for example, the 169 would end up being 169 over 100, because this is the 100th place. If I take the square root of this, I get 13 on the top and I get a 10 on the bottom, so it works. So the 10th place doesn't work, the 100th does, the thousandths doesn't work, but the 10,000ths does work. So you just have to watch with the decimals, checking the next one, like if we were looking at this one without a calculator. 35 is not on our list, so we'd know right away that this one's not going to work. So I'll practice both ways with all the practice, so that if you're going into Essentials, you're just checking with your calculator. If you're going into Intro, you're going to use this strategy. Okay, so for the practice here, complete the value to find whether each decimal is a perfect square or not. So for the first one, 70.5, so 705 is higher than your list. So, but just even seeing that it's one decimal place, you know it's not going to work. So here they took the square root, and you can see there's no pattern and it does not end. So the answer would be no, this is not a perfect square. So for the next one, 576 is higher than your list. So if you take the square root of that with your calculator, or if you even check 576 to see 576, what would be the value that would work there. So it's 24 times 24 gives you 576. So the square root, if you use your calculator, is 2.4. So like I said, if you weren't using a calculator, I wouldn't be giving you 576 because it's too high. I'm only expecting you to memorize the first 20. So you would need to use your calculator for this one. So this one is a terminating decimal, so then it would be considered a perfect square. Okay, If I take the square root of 0.25, with my calculator I get 0.5. So thinking about how that would work without doing this with a calculator. So if you're trying to work without a calculator, you're thinking about, first of all, is 25, those digits 25, are they on your list? So yes, they are. So that meets the first criteria. And then you're thinking about those two decimal places. So 0.25 written as a fraction would be 25 over 100, right? That's the 100th place. So if I take the square root of that, I get a 5 on the top and a 10 on the bottom. So 5/10. So if we started as a decimal, we switch back at the end. So it would be a 5 in the 10th place. So you can do it without a calculator, working through changing it to a fraction and then changing it back to a decimal. So either way, since this decimal ends, we've got a termination, which means yes, 0.25 is a perfect square. You check the next one if you're trying to do it without a calculator. 25 is good, but if you look, we've got in the 10th place here. So if you're thinking of trying without your calculator, think of what that might look like. That's a 25 on the top, which is good. It's just the bottom for, this is the 10, so you'd put a 10 on the bottom. So when you're trying to evaluate this, you get a 5 in the top, but the square root of 10 is not, does not work for us because it ends up being a decimal. So if we want the exact number with our calculator here, so with a calculator, we're looking at getting 1.58, 11, and so on. That kind of keeps going there. There's no pattern for repeat. So that would be non-repeating, non-terminating. So then we're looking at no, 2.5 is not a perfect square. So sometimes it can be confusing because 25 looks good. It's just the fact that it's not the right decimal places is why it doesn't work there. Okay, so for the practice for this, we're working on calculating the number whose square root is. So this is back to the beginning again. So for the practice, pause the video, work through all the practice, see as much as you can get done, and then play the video to get the answers. Okay, so I'll go through the answers with you after you play the video. So pause it, try and do as many as you can, and then work through correcting. So for this one, we got 1 times 1, 4 times 4. So on the top, we have a 1. On the bottom, we have a 16. So if you take the square root of 1/16, you would get 1/4. This one is 2/7 times 2/7. 2 times 2 on the top, 7 times 7 on the bottom. So that's 4/49. So here the square root of 1/4 is the square root of 1/16, right? Looks kind of funny because 1/16 is way smaller, but when you take the square root of 1/16, you get a quarter. Okay, and that's because when you multiply a fraction times a fraction, right, something that's less than 1 by something that's less than 1, you're ending up getting a smaller number there, right? We always think about multiplying, getting something bigger, but if you're multiplying something that's less than a whole, then you're actually getting something smaller. So here we're taking 0.6 and multiplying it by 0.6. So 6 times 6 is 36. And then I've got those two decimal places to incorporate in. So 0.36. Here, a 1 times 1.1 times 1.1. 11 times 11 is 121. And then I've got 2 decimal places to incorporate in. So remember, like I said, don't feel bad if you're using a calculator, especially next year. We're kind of preparing for next year now, where if you're going to essentials, you get the calculator 100% of the time. If you're going into intro, this content would be in a unit next year that you wouldn't be using your calculator for at all. So you need to make sure you've got those skills for baseline to prepare for the harder level stuff for next year. Okay, so question 2, identify the fractions that are perfect squares. First one's done for you. So for this one, is the numerator a perfect square? So yes, 25 is 5 times 5. Is the denominator? Yes, 7 times 7 is 49. So then this fraction would be a perfect square. 36 is 6 times 6. 121 is 11 times 11. So this one works as well. Okay, numerator is a no. We've got one for 16, but not one for 17. 25 is good. So because one doesn't work, then they both don't work. And then 9 is 3 times 3, so that's good. 100 is 10 times 10, so that one's good. So that fraction is a perfect square. Now we're working with the perfect squares and finding the square root, so we just have to think of numerator and denominator separately. So this is going to give us 7 tenths. This one's going to give us 5 twelfths. So we're breaking the numerator down, breaking the denominator down. Remember, you can use your sheet for this to help you with what the factors would be. One's kind of tricky to remember, that just 1 times 1 gives us 1, and then 4 times 4 is going to give us 16. And then last one here, it's 3 times 3, and then 400 is on our list, it's right at the end, so that's 20 times 20. Okay, here they're asking you to use a calculator. So for all of these, they're higher than our list. So then I would say to use a calculator. So it's only when the digits actually make something lower than 400 that go ahead and try and do it without. So for 8.41, if you're taking the square root, we're getting 2.9 for that one. For the next one, 0.0676. So even the 676 is too high on our list there. This one is 26 times 26. So with all those decimal places, though, it would be 100 times 100. Okay, and then 51.125, square root of that. That's a really high one there for our list to have on there. So 51.125. This one gives us a long decimal, so I'm just going to put some dots after because this one does not end there. It does not terminate and it does not repeat. And then 6.25, we've done this one already, so you might recognize 6.25, it's 25 times 25. So to get that decimal place there, 2 decimal places, we need 1 in the answer. Okay, move on. Which decimals are perfect squares or not? So remember, not going into essentials, try and test this with what you know now. And if you are, you can use your calculator. For square root of 1.44, we're looking at the 144 is good. That's the 12 times 12. And then to get the 100th place, we need a 10th times a 10th. So the square root is a decimal that terminates, so it is a perfect square. 30.25, that one's higher than the list, so you're going to have to use a calculator to check that one. It actually works out, it's 5 times 55 to get the 3025. So getting those 2 decimal places there, you need a 10th times a 10th. So it does terminate, so this is a perfect square. So looking at this one, you might already know 85 is not on our list. This one is not going to be that one that works. You're going to use your calculator to find the square root of that one. So it's about 2.9 dot dot, it keeps going there. So it does not terminate. So the square root is a decimal that is non-repeating and non-terminating. So is not a perfect square. Okay, and then the 256 is a little, or is on our list, right? So we might recognize that one, or we should recognize that one. And then thinking about the decimal places there, I said 10th didn't work, 100th did, 1000th didn't, but 10,000th did. So this one does work. 16 times 16 gives us 256. And to get the 4 decimal places, we need 2 decimal places times 2 decimal places. So this one does terminate. So this is a perfect square. Okay, and then this is just another way to think of the fractions and the decimals. It's a visual of the area model. We're used to using the area model for whole numbers, but it works for fractions and decimals too. So you have to think of, for this one, the area is the shaded region out of a total of the whole block there, right? So if you look at this, I'm looking at 3 units on the side here out of a total of 5 units. So I've got 3 shaded in. I'm just looking at side length. So 3 shaded in out of 5. So my side length would be 3/5. So to get the area, I'd be taking 3/5 times 3/5, right? Length times width. So that would give me, I guess they want slow steps here. So it'd be a 3 times a 3 on the top and a 5 times a 5 on the bottom. So the area would be 9/25. Okay, so the area here is 9/25. So now that you know how to do that one, maybe try the next one. So we're looking at how many are shaded out of a total how many. So 1, 2, 3, 4, 5, 6 for the side length. So 6 out of 7 are shaded. So the area would be 6/7 squared, right? 6/7 times 6/7, length times width. So 6 times 6 is 36. 7 times 7 is 49. Okay, so the area is 36/49. Okay, so now it's strange to think of it in fractions there, but this is trying to relate it to our original area diagram, and then it'll help with taking square roots of fractions and decimals. Okay, same idea here. We're looking at a length of a decimal number. So to find the area, it'd be 5.4 times 5.4. So you can use your calculator for that since it goes over our table there, the 20 times 20. So that's going to give me 2,914, but then I've got to put in my 2 decimal places. So the area here would be 29.14 units. For the next one, the length is 21, or 2.1. So we're looking at 2.1 squared. So once again, this is past our list of 20. It's close. 21 is right at the edge there. But 2.1 times 2.1 is 4.41. So that would be our area of units there. Okay, so it can be done the same with decimals. We're just multiplying the length times width or the side times side. So working backwards with that, now they've given us what the area is. So for example, for the first one, we've got 9 blocks shaded in out of a total of 100. So to find the side length, we're taking the square root of 9/100. So once again, that's thinking of what times what makes 9 and what times what makes 100. So 9 can be broken down into 3 times 3. 100 can be broken down into 10 times 10. So therefore, when you take the square root of that, you're getting a 3 on the numerator, a 10 on the denominator. And you can check that that matches up with our side length here. So it'd be 3 shaded out of a total of 10. Give us 9/100. Okay, likewise for the next one, we've got 25 shaded out of 36. So looking at 25, that's 5 times 5. 36 is 6 times 6. So the answer would be 5, 6. Check with your diagram. I've got 5 shaded out of a total of 6 for the side length. Okay, and lastly for the decimal, my area is 0.01. So I'm taking the square root of 0.01. So what would give me, so what times itself gives me 0.01? So thinking about this, you could take, first of all, definitely use your calculator if you're going into essentials. If you're not, you can think about this as 1/100th, right? Thinking about it in fraction form might be a little bit easier. 1 times 1 gives me that 1, right? Like I'm taking the square root of this. Square root of 1 is 1. Square root of 100 is 10. So switching 1/10 back into a decimal would be 0.1, right? So looking at how we get those numbers, it's often easier to change it to a fraction. And then for the last one, that number is a lot higher than our list of for 20 times 20, which is 400. So we're probably having to use our calculator for the 4624. So when we take the square root of that, we end up getting 6.8. Okay, and then that's it for square roots of fractions and decimals. Okay, have a great day.